Hello everyone, welcome to Husky Math. In this video, we will learn how to determine a function is increasing or decreasing using derivatives. Okay, so this concept is also known as monotonicity, and it helps us to understand the behavior of the functions and is one of the most important application of derivatives. Okay, so if we make a graph and see the graph of a particular function, then it's easy to see whether the function is increasing or decreasing. For example, if I make a graph here, so here's I made a function which is increasing as well as decreasing also. Here we can clearly see that from x equals to a to b the function is increasing, and from x equals to b the function is decreasing up to c. So this is what a function looks like in a graph. Okay, so now if I choose any point where the function is increasing, suppose if I choose a point P here, and if I try to draw a tangent at this particular point P, and if you notice that this tangent is making an acute angle with the positive direction of x-axis, and let that be theta. And if I try to write the slope of this line, then it will be tan theta. We know that slope of a line is written as tan theta, and this tan theta will always be positive as far as the theta is at an acute angle. Okay, so here tan theta is the slope of the line, and in derivative we write this slope as dy over dx. That means dy over dx should be greater than 0, or you can also write dy by dx as f dash of x. So f dash x should be greater than or equal to 0 whenever the function is increasing. And similarly, if I choose a point on the decreasing side of this function and let that point be q here, and if I make a tangent in this particular point q, then it will be like this. Now as you can see that this tangent is making an obtuse angle with the positive direction of x-axis, and let that be phi. And if I have to write the slope of this tangent, then it will be tan of phi. Now since this phi is an obtuse angle, that means this angle lies in the second quadrant, and in second quadrant tan is always negative. That means this tan phi will be less than 0, and slope is written as dy over dx. That means dy over dx should be less than 0, or we can also write this as f dash x is less than 0. That means my conclusion is that whenever the derivative of a function is greater than 0, then that time we can say that the function is increasing, and whenever there is the negative value of the derivative, then we can say that the function is decreasing. So here I have summarized everything whatever we have learned in that from that figure. So in number 1 I have written, and this you have to remember while solving this increasing and decreasing functions in this chapter. So in number 1 I have written that if f dash of x is greater than 0, then the function is strictly increasing. And in number 2 I have written that if f dash x is greater than or equal to 0, then we say that function is increasing only. So there is a difference between strictly increasing and increasing. Okay, so you have to remember this. In number 3, if f dash x is less than 0, then fx is strictly decreasing, and similarly if f dash of x is less than or equal to 0, then fx is decreasing only. We do not say strictly decreasing that time. So here one thing is very important to note here, and that is if a function is strictly increasing or decreasing, okay, whether it's strictly increasing or strictly decreasing, then that time we can say that that function is increasing and decreasing. That means if a function is strictly increasing, then we can say that the function is increasing only also. But the reverse is not true. That means if a function is increasing, that does not mean that the function is strictly increasing. So this you have to keep in your mind. Now let's begin with some questions. Question 1. Show that the function fx equals to 5x minus 2 is strictly increasing on real number r. So here the function is given as fx equals to 5x minus 2. Now we will differentiate both sides with respect to x, then we will get f dash of x, and if I differentiate 5x, then it will be 5 only, and the differentiation of minus 2 is 0. Now since we have got the value of f dash x as 5, and we know that this 5 is greater than 0. That means here the value of f dash x is greater than 0, and we know that if f dash x is greater than 0, then we can say that the function fx is strictly increasing on real number r. Question 2. Here we have to show that this function is strictly increasing for all x greater than 0. So here note that they have already said that the value of x is greater than 0. That means the value of x is positive only, the positive real numbers. Now, since the given function is fx equals to x minus 1 e to the power x plus 1, so we need to differentiate here both sides with respect to x. Then we will have f dash of x here equals to, here let us use the product rule. So let us keep x minus 1 first and differentiate e to the power x, and differentiation of e to the power x is e to the power x only, plus let us keep e to the power x at first, and differentiation of x minus 1 is dtx of x is 1 and dtx of minus 1 is 0, so it will be minus 1 only, plus dtx of 1 is 0. That means f dash of x equals to x minus 1 e to the power x plus e to the power x. Now let us take out common e to the power x, then we will have e to the power x, x minus 1 plus 1, and hence f dash of x equals to e to the power x into x. Now here the question had already said that x is greater than 0. That means this x will always be positive, and another function is there e to the power x, and we know that exponential function is always greater than 0. That means this is the product of both positive numbers, and hence the product will also be greater than 0. That means f dash of x is greater than 0, and this implies the function fx is strictly increasing for all x greater than 0. Question 3. Show that the function fx equals to log of sine x is strictly increasing on 0 to pi over 2, and this function is strictly decreasing on pi by 2 to pi. So let us first differentiate the given function, that is fx is equal to log of sine x. So differentiating both sides with respect to x, I will have dx of log x is 1 by x. So first I will have 1 by sine x, and using chain rule dx of sine x is cos of x. So this implies f dash of x equals to, see, cos over sine can be written as cot of x. Now this cot of x is sometimes positive and this cot of x can be sometimes negative. So this is our quadrant, where first quadrant lies between 0 to pi by 2 and second quadrant is from pi by 2 to pi, and similarly third and fourth. So here in question they have given the interval as 0 to pi by 2. So 0 to pi by 2 means first quadrant. So in first quadrant we know that all trigonometric functions are positive. So in A the interval is given as 0 to pi by 2, which is our first quadrant. That means our x lies between 0 to pi by 2. So in first quadrant all trigonometric functions are positive. That means cot of x will also be positive, and since cot of x is our f dash of x, that means f dash of x is positive or greater than 0. This means the function fx is strictly increasing between 0 to pi by 2. Number B, the interval is given as pi by 2 to pi, and looking at the graph you can see that pi by 2 to pi means our second quadrant. So here the interval is pi by 2 to pi. That means our x lies between 90 degree to 180 degree. And we know that in second quadrant only sine and cosec are positive. All other trigonometric functions are negative. That means cot x is negative in this interval. So that means cot x is less than 0. And since cot x is f dash x, so f dash x is less than 0, and this means that the given function fx is strictly decreasing on the given interval pi by 2 to pi, and hence the question. Question 4. So that the function fx equals to x square minus x plus 1 is neither increasing nor decreasing on 0 to 1. Here the interval is given from 0 to 1. So in a number line, let us mark 0 here and 1 somewhere over here. And let us first differentiate the given function. Since fx equals to x square minus x plus 1, on differentiating both sides, we will get 2x minus 1. Now, in this type of question, we have to, for a while, suppose f dash of x equals to 0. This we have to do, okay. So, while putting f dash x equals to 0, we can write 2x minus 1 equals to 0, and this means 2x equals to 1, and hence I will get the value of x as 1 by 2. This x equals to 1 by 2 is our critical point. This is called a critical point. And let us mark this critical point on the number line. Then 1 by 2 will be somewhere in the middle, which means 0.5. Now, since our given interval, that is 0 to 1, has been divided into two intervals, that is from 0 to 1 by 2 and from 1 by 2 to 1. So, my interval is, one interval is this, other one is this. Now, let us choose any point between 0 to half. Let us choose 0.1 from here, and let us put this 0.1 in f dash of x. So, if I put the value of x as 0.1, then I will have 2 into 0.1 minus 1, which will be equal to 0.2 minus 1, and this is a negative of 0.8. That means this is less than 0. So, my f dash x is less than 0 between 0 to half. That means the function is decreasing in this interval. Now, let us choose any point between 1 by 2 to 1, and let us choose that point be 0.6, and let us put this 0.6 in f dash of x. Then we will have 2 into 0.6 minus 1, this will be equal to 1.2 minus 1, and this will be equal to 0.2, which is a positive number. That means the function is increasing in this interval. So, since this function is decreasing from 0 to 1 by 2 and again increasing from 1 by 2 to 1, that means this function is neither increasing nor decreasing between 0 to 1, because we say a function is increasing only if it is increasing entirely from 0 to 1, or we say a function is decreasing if the function is decreasing entirely from 0 to 1. But here from 0 to 1, this function is increasing as well as decreasing also, so we cannot say that function is increasing or decreasing between 0 to 1. So, here this method you have to remember, this is called the critical point method, where we have to divide the given interval into sub-intervals and check in each intervals whether the function is decreasing or increasing. Find the intervals in which the given function is increasing and decreasing. So, we have to find the interval at which the function is increasing and at which interval the function is decreasing. And since they have not mentioned the intervals, so we will consider the entire real number line. So, first let us make my entire real number line, that is from minus infinity to plus infinity. So, let us differentiate the given function. If I differentiate the given function, then my f dash x will be 3x square minus 12 to the 24x plus 36. So, and here in order to find the critical point, first we have to factorize this f dash x. So, in order to factorize, first let us take out 3 common here, then here it will be x square minus 8x plus 12. Now, splitting the middle term, we will factorize minus 6x minus 2x plus 12. So f dash x is equal to 3 of x is common, x minus 6 minus 2 is common, x minus 6. Hence, on factorizing f dash x, I got 3 times x minus 6 into x minus 2. Now, in order to find a critical point, we have to put f dash of x equals to 0, and if I put f dash x equals to 0, that means 3 into x minus 6 into x minus 2 equals to 0. Now, since 3 is a non-zero number, so we can take 3 to other side, then we will only have x minus 6 into x minus 2 equals to 0. So, from here we got the two values of x, that is x equals to 6 and 2, and these two values are the critical points for this problem. So, let us mark this 2 and 6 on the real number line, then let 2 be here and 6 be here. Now, as you can see that this entire real number line has been divided into 3 sub-intervals. Now, we will choose any point from these 3 intervals and check whether f dash x is positive or negative. So, let us choose a point from this first interval. Let that point be 0, because 0 lies between infinity to 2. So, if I put this 0 here in this f dash of x, then we will have 3 into 0 minus 6 into 0 minus 2. So, here it will be 3 into minus 6 into minus 2, and if I multiply all this, I will get plus 36, and this 36 is greater than 0. That means the value of f dash x on this first interval is positive. Now, let us choose any point between 2 to 6 and let that point be, let us say 5. Now, let us put 5 here in the value of f dash x, then we will have 3 into 5 minus 6, 5 minus 2, then it will be 3 into minus 1 into 3, and this will be equal to minus 9, which is less than 0. That means the value of f dash x will be negative. So, in this interval my f dash x is negative. So, similarly, if you choose any number between 6 to infinity and put that value in f dash x, then you will surely get positive. That means this function is increasing from minus infinity to 2, and from 2 to 6 it is again decreasing, and from 6 to infinity it is again increasing. So, the question was asking to find at which intervals this function is increasing and at which interval this function is decreasing. Now, it is clear that fx is increasing on which interval? Minus infinity to 2. So, here we will close 2, that means we will include 2, because the question is saying that it is increasing only, because on increasing the function could be greater than or equal to 0. That is why I am putting 2. Union, it is increasing from 6 to infinity also, and here also we will close 6 open bracket infinity. Hence, on this interval the function is increasing, and this function is decreasing from on 2 to 6. Here we are closing the interval because they are only saying increasing and decreasing. If they had said strictly increasing and strictly decreasing, then this answer would be in open bracket. So, we could not include 2 and 6 that time. Question number 6. Find the intervals in which this function is decreasing. So, the interval is not given, that means the interval is entire real number line. Let us differentiate. First, fx is x by 3 plus 3 by x. So, if I differentiate, we will have 1 by 3 plus 3 into differentiation of 1 by x is minus 1 by x square. So, f dash of x is equal to 1 by 3 minus 3 by x square. So in order to find a critical point, let us take the LCM here. It will be 3x square, and in numerator it will be x square minus 9. And let us factorize the numerator. Then it will be x plus 3 times x minus 3 whole divided by 3x square. Now looking at the values here, we can find the critical point. First of all, as you see, there is x plus 3. So if I equate this with 0, then we will get the value of x as minus 3. And from here, I'll get the value of x as 3. And we have to also assume this x. This x is, if I put this x square as 0, then I'll get x as 0. So here in this case, I'll be having 3 critical points, that is 0, minus 3 and 3. Let me repeat you again. This 0 I got from the denominator because there is x square. If I equate this x square with 0, then it will be 0 only. And if I equate this x plus 3 with 0, then I'll get minus 3. And from x minus 3, I'll get plus 3. Now let us mark this 0, minus 3 and 3 on the real number line here. So here it will be 0, minus 3 and 3. Now this interval has been divided into 4 sub-intervals. So we will choose point one by one. Now let us choose a point, any point between 0 and 3, and let that point be 2, and let us put this 2 here in f dash of x. Then I'll get 2 plus 3 into 2 minus 3 whole divided by 3 into 2 square. So it will be 5 into minus 1 by 4 3s are 12, and I'll get minus 5 by 12. That means I'll getting a negative value in this interval. Now let us choose any point between minus 3 to 0. Let us choose minus 1 and let us put it here. Then it will be minus 1 plus 3, minus 1 minus 3 divided by 3 into minus 1 square. So here it will be 2 times minus 4 divided by 3, and this is obviously a negative number. That means this function is decreasing, or f dash x is negative here also, between minus 3 to 0 also. Now similarly, let us assume any point which is greater than 3 to infinity. So let us choose 5 here. So if I put 5 here in this f dash x, then it will be 5 plus 3, 8, which is positive. 5 minus 3 is positive, and in denominator it will be positive. So overall the f dash x will be positive between 3 to infinity. And similarly, you can check in this interval, that is minus infinity to minus 3, this function will be positive here also. That means this function is decreasing from minus 3 to 0 and from 0 to 3. So here the question was asking to find at which interval this function is decreasing. So my answer will be from minus 3 to 0 and from 0 to 3. So here one thing is to note that we will not include 0 in our answer, because as you see that if we include 0 here, then in f dash of x there will be a problem, because in denominator there is x, and if I put the value of x as 0, then there will be 0 in the denominator which is undefined. So we will exclude 0 as our answer. That means the interval at which this function is decreasing will be from minus 3 to 0, excluding 0, union from 0 to 3, but including 3. So we are including minus 3 and plus 3 because the question was saying at which interval this is decreasing. But if the question had asked at which interval it is strictly decreasing, then that time we have to exclude minus 3 and 3 also. So this is our required answer. Question 7. Find the intervals in which fx equals to sin x plus cos x is strictly increasing and strictly decreasing. Here the interval is given from 0 to 2 pi. So here first let us differentiate the given function, that is fx is equal to sin x plus cos x. So if I differentiate, I'll have f dash of x equals to cos x minus dx of cos x is minus sin x. Now in order to find the critical points between the interval 0 to 2 pi, first let us make a number line where my interval is from 0 to 2 pi. So in order to find the critical points between this interval, let us put f dash of x equals to 0. On doing so, I'll get cos x minus sin x equals to 0, and this will imply sin x equals to cos x. Dividing both sides by cos x, I'll have sin x over cos x equals to 1, and sin over cos is tan x equals to 1. Now we have to find the values of x for which tan x will be equal to 1. For that, let us make our quadrants. So here's my 4 quadrants, and as you can see that the value of tan x is plus 1. That means tan x is positive 1, and we know that tan is positive in 2 quadrants, that is in first quadrant tan is positive and in third quadrant tan is positive. That means we can find the value of x from these 2 quadrants, and from the first quadrant everyone know that tan 45 degree is equal to 1. That means the value of x is 45 degree at which it is equal to 1. That means my critical point is pi by 4 from the first quadrant, and from the third quadrant it is 5 pi by 4. See, how to do that is, we know that from trigonometry that tan pi plus pi by 4 can be written as tan pi by 4 only, because tan pi plus theta is tan theta only, and this implies tan, if I add pi plus pi by 4, then I'll have 5 pi by 4, and this equal to tan pi by 4, and tan pi by 4 is plus 1. Hence the value of x is 5 pi by 4, and 5 pi by 4 lie in third quadrant. So that means we have got the value of x, which means we have got the critical points. So here pi by 4 and 5 pi by 4 are the critical points. Now let us mark them on the number line. Then I'll have pi by 4 here and 5 pi by 4 here. Now let us choose any point between this interval. Let us choose 30 degree, and if I put this 30 degree here in this equation, then I'll have cos 30 minus sin 30 degree, and cos 30 is root 3 by 2 minus 1 by 2, and if you simplify this, then you will get this value is positive. That means f dash of x is positive between this interval, that is from 0 to pi by 4. Now let us similarly choose a point from the second interval, that is from pi by 4 to 5 pi by 4, and let us choose 90 degree from here, and let us put it here. Then I'll get cos 90 minus sin 90, and cos 90 is 0 minus sin 90 is 1, and this equals to minus 1, which is a negative value. That means this f dash of x is negative in this interval. So similarly, if you choose a point from 5 pi by 4 to 2 pi, then you will get this as positive. Okay, that means this function is increasing from 0 to pi by 4 and decreasing from pi by 4 to 5 pi by 4, and again increasing from 5 pi by 4 to 2 pi. And the question is asking at which interval this is strictly increasing, and we see that it is increasing from 0 to pi by 4 and from 5 pi by 4 to 2 pi. So my answer for strictly increasing will be fx is strictly increasing on 0 to pi by 4. See, I am not closing pi by 4 because they are saying strictly increasing, union open interval 5 pi by 4 comma 2 pi. See, I have written all in open intervals because as you can see in the question also, the value of x is greater than 0. It is not equal to 0, and the value of x is less than 2 pi, not equal to 2 pi. That's why I am opening the bracket at 0 and 2 pi and not closing pi by 4 and 5 pi by 4, because the question is saying strictly increasing, and for that it should be always greater than 0, not equal to 0. And similarly, the function fx is strictly decreasing on open interval pi by 4 to open interval 5 pi by 4. So these are the required answer for this question. Question 8. Find the values of x for which the function fx equals to x to the power x and x is greater than 0, is increasing and it is decreasing. So here the question is asking to find the values of x. So this means we have to find the intervals. So the given function fx equals to x to the power x. So before differentiating we can put logarithm on both sides. So it will be log of fx equals to log of x to the power x. So it will be log of f of x equals to x into log s. Now let us differentiate both sides with respect to x. Then ddx of log of fx will be 1 by fx, and by chain rule derivative of fx is f dash x equals to, let us use the product rule here. So keeping x first, differentiating log x, it will be 1 by x, plus keeping log of x and differentiating x, we will get 1. So this implies f dash of x by f of x equals to 1 plus log of x, and this implies f dash of x equals to fx into 1 plus log of x. Now since we know the value of fx, so let us put it here. The function fx is x to the power x and it is 1 plus log of x. See, fx is increasing when f dash of x should be greater than or equal to 0, and since the value of f dash of x we have got as x to the power x into 1 plus log of x, so this should be greater than or equal to 0. Now here if you note that the value of x is greater than 0, that means x is always positive, and therefore x to the power x will be positive. So let us divide both sides with x to the power x, then I will have 1 plus log of x greater than or equal to 0. So from here I got log of x is greater than or equal to minus 1, and since this logarithm is a natural logarithm, so the base is e, and we know that here in this case we can write e to the power minus 1 as x. So that means this implies x is greater than or equal to e to the power minus 1, and hence x should be greater than or equal to 1 by e if the function should be increasing. So from here I got an interval, that is x should belong to 1 by e to infinity. So at this interval the function is increasing, and similarly fx will be decreasing if f dash of x is less than or equal to 0, and the value of f dash of x is x to the power x, 1 plus log x should be less than or equal to 0, and dividing both sides by x to the power x, I will get 1 plus log x less than or equal to 0, and hence log of x is less than or equal to minus 1. Therefore this implies x is less than or equal to e to the power minus 1. So this implies x should be less than or equal to 1 by e. That means the value of x should belong to 0 to 1 by e. See here I am opening at 0 because the question is saying that the value of x is greater than 0. So that's all for this video. We learned how to use derivatives to determine the intervals where these functions are increasing or decreasing. Okay, so keep practicing more questions for your understanding, and thank you for watching Husky Math. See you in the next video.